Let me turn the thing on. Okay, lead 204, lead 206, lead 207, and lead 208. What do these numbers indicate? The 204, the 206, the 207, and the 208. What does that number mean? Hold on. Go ahead, Isaiah. It's the mass number. Okay, they're whole numbers. They're mass numbers. And the mass number is equal to the number of protons and neutrons. Okay? It says the average atomic mass of lead is 207.2. This is the atomic mass. The average atomic mass. Usually a decimal in there because it's an average. Which of these isotopes, the 204, 6, 7, or 8, is going to be the most abundant and why? Rob, go ahead.
Lead 207.
Because?
It's the closest to 2702.
That's what I would say. Okay, this lead 207 is closest to the average, so therefore this lead 207 is the most abundant. Okay, number 2. What do all isotopes of an element have in common? Okay, I heard both answers are correct. Atomic number, so they have the same atomic number, and they have the same number of protons, because atomic number was equal to number of protons, nuclear charge, and electrons in a neutral atom. All right, why are carbon-14 and nitrogen-14 not considered isotopes? Isaiah, hold on one second. Go ahead. Tell me why.
Different number of protons.
I love it. They have different numbers of protons. I'm going to switch to a skinnier pen. So, number of protons. Do you know how many protons are in the carbon-14?
No.
Izzy, do you know? Do you know where you would find it if you were to look for it? 6, because it's the atomic number and it's what's given to us on the reference table. How many protons in nitrogen-14? 7. It's the next one up. They have different numbers of protons and they have the same mass numbers. All right, write the atomic symbol for uranium. I'm gonna do it in purple because why not? Okay, uranium symbol is U, right, Olivia? How many protons does uranium have? 90 what? 2. I like it. Okay, so right now I've got uranium with 92 protons. Its atomic number is 92. Atomic number and number of protons are the same thing. I need to figure out this mass number that's up in the upper left-hand corner. Michelle, how do you find mass number? Say it loud. Adding the protons and the neutrons. Okay. It tells you one isotope has 142 neutrons. How do I find this mass number up here? Give her 1 second. Michelle, do you know how to find this mass number? If they gave you neutrons and they told you the protons was 92, what are you going to do with those two numbers? Add them together. So what do we get when we add them together? What? Okay, good. There was a lot of numbers coming out of there. Oh, you did the second one too. All right. So then we've got uranium 92 over here. This one has 146 neutrons, so it's not the same number of neutrons. So we're going to have 238 over here. These are the isotopic notations for both uranium isotopes. What's up, Buttercup? Go ahead, make it easy because I'm old.
Can't we just say that they're not isotopes because they're not the same element?
Depends. If the question says, explain in terms of subatomic particles why they're not isotopes, then you must say that they don't have the same number of neutrons. Okay? You have to talk about the subatomic particles if they say in terms of subatomic particles, which they probably will. If they just say, why are they not isotopes of each other? You're right. The statement of they're not the same element, they can't be isotopes of each other, then that's true. But be careful with the way they ask the question, okay? All right, number 5. I think I have number 5 on the next page, so I can go to the next page. And this is important when you're writing it for the test next week. I'm telling you I'm going to give you one of these. You're going to have to write it out. This is points that I'm telling you is going to be on there. Right, Alana? Easy points. Easy peasy lemon squeezy. You're going to take the abundance, change it into a decimal. 6% becomes 0.06. You're going to multiply by its mass. In this case, they didn't give us a mass. They gave us a mass number, so I will use that. If they give us a mass, be sure to use the mass. Don't use the mass number. Sometimes they give you the actual atomic mass. That's what you're going to use. They didn't here. Plus 0.92 times 56 plus 0.02 times 57. All right, now I need your help. Did you guys get a number, an answer here? What'd you get, Izzy? 55.9 sounds good to me. And the reason I know that it sounds good to me is because I know that my answer should be closest to 56. Because it was 92% of the time 56. 55.9 is pretty close to 56. All right, we do the next one. 0.95 times 14 plus 0.03 times 15 plus 0.02 times 16. I take the percentages, I made them to decimals. I multiplied it towards or by its mass number, and now I add them all. I do all this fancy math, and what do I get for a number? Go ahead, Willow. Say it again, 14.07? Okay, 14.07. And somebody asked me what the units for this were. The units are atomic mass units, okay? So I could write 14.07 with this funky U-shaped thing. That means atomic mass units.
You can say AMU though, right?
You could say AMU, you could say little U thing, and even for these, just writing the number would be okay. All right, last one on this page, we've got 0.80 times 127. They're getting repetitive. 0.17, whoops, I don't want parentheses around that. Keep it consistent. Times 126, and 0.03 times 128. And then my answer better be close to 127. It's probably going to be 126 point something. All right, what's my answer? 126.86. Okay, and then we can put the U if we want. Okay, it's close to 127. 0.99 times 1, 0.008 times 2, and 0.002 times 3. My answer should come out closest to 1. Okay, anybody have a number for me? 1.0. Oh gosh, I totally didn't catch that. 0.012. Okay. Atomic mass units. All right. Now they give it to us in words. This is the one that was funky. We discovered that doesn't add up to 100%. So our answer is a little bit off, but we'll write it out anyway. 0.241 times. Oh, if you're having trouble with these, take a highlighter if you want, and you could do 24.1% of all the isotopes have a mass of 75.23. Do it in one color. 48.7 have a mass of 74.61 in another color. And then I'll do 22.1 of this 75.2. So now, visually, I can see what two numbers go together. Okay? And I don't have to be like reading it every single time as carefully. So 0.241 times 75.23 plus 0.487 times 74.61 plus 0.222 times 75.20. and we did not get a number that we expected. We got 71 point something, right? 71.2. Because the percentages didn't add up to 100. Now, they said use your periodic table to determine which element this is. Alright, let's pull up a periodic table. Let's just see. Just for fun. We could find a periodic table. Where are we? Periodic table. I don't want that one. I want this one. Let's see if it works, because this question had some problems. Rotate clockwise. Okay, so we got 71.2. Let's see if we can find one that's 71.2. Of course not. It doesn't exist on there. So it would be either gallium or germanium, because we're looking for one that had an isotopic mass of 71.2. It makes sense that this was messed up, this question. So, all right, last one. Maybe this one works out a little bit better for us. No, it's not the last one. You guys getting the hang of these? Okay, they're getting a little bit repetitive. Yeah, a little bit. Just a little itty bitty bit. Well, it's only my 14th time doing them today, so 0.0435 times 49.9461. Oh boy, we're not going to fit this all on the page, are we? 0.8379 times 51.9405 plus 0.095 times 52.9407 plus, and I got to write it down here, 0.0236 times 53.9389. Okay, do we have an answer for this one? 51.99. Do we agree? I get a confirmation of that? Okay, so then we go back to our reference table. Let's see if we can find one that's close to 51. Oh, here we go. 51.996. So what element is this probably going to be? Chromium. I think we deserve a smiley face for that one, because the other one was not good. All right. Calcium has 3 different isotopes. One has a mass of 35, the other has a mass of 41, and the other one has a mass of 40. Which one's the most abundant? Go ahead, Cap.
40 AMU one.
40 AMU. Because when we look at calcium on the periodic table, it's 40.08 as its average atomic mass. So this one is going to be the most abundant. And you can't see anything that I'm writing. Okay? Not that it was nice and neat. All right, last one. 0.0435 times 39.946 plus 0.8379 times 41.941 and crumb cakes, 0.95 times, I thought I was going to be able to fit it on the one line, but I can't, plus 0.0236 times 43.939. Does anybody have a number for us? Go ahead, Sophia. 41.99. We have a confirmation of that? Yes? And somebody else got that number? Okay. So let's go with it. It's 41.99. What element is it? It's not on here. So, we weren't? Oh. What is the average atomic mass of X? 41.99. Good? Isaiah, you good? You just stretching or you need me? Oh, okay. Of course. All right, let me stop the recorder for a second.